Okay, so we'll be doing some limit questions, and these are the 5 examples we'll do right now. We'll tackle these 5 examples, and we'll just start right now. The first one is to evaluate the limit as x approaches minus 2 of 7x squared plus 2x plus 1. This is very easy to do. Of course, this limit can be evaluated just by plugging in, by just substituting the value x equal minus 2. So what do we get? 28 minus 4 plus 1, so it's 25 to the 4. Now we move on to a harder example. The limit as t approaches 4 of 1 over t divided by t minus 4. First of all, we try to evaluate by plugging in. So the limit of the numerator is 0, is 1 over 4 minus 1 over 4. And the limit of the denominator is also 0. So what I have here is an indeterminate form that is 0 over 0 that is indeterminate. So we'll try to work around it if possible. The first thing we can do is really arrange the numerator. Numerator itself is a difference of two fractions, so we can just write it in a nicer way by figuring out that 4t is the common denominator. And then that's what we get here. 4 minus t divided by 4t, t minus 4. And this is nothing but, writing this way. Now in this case, what do? We notice that, this is just the limit as t approaches 4 of minus t minus 4 over 4t. Now I can cancel out the t minus 4 on top and on the bottom to get something nice. And this limit can be evaluated by just plugging in, which is minus 1 over 16. The idea here is that we need to cancel the indeterminate, we need to get rid of the indeterminate form. This is the main idea when we get a 0 over 0. Now let's move on to a slightly harder example. The limit as h approaches 0 of square root of 4 plus h minus 2 over h. Now the limit of the numerator, first we try to plug in, is of course, in that limit you can plug in, you get 0. And in the limit of the denominator, you obviously get 0. So it's indeed a 0 over 0 that is indeterminate. Now in this case, what we could do is try to get rid of the square root. It's a bit informal. So what we can do here is multiply by what we call the conjugate. If I multiply by something on the top, I have to multiply it on the bottom, so that I don't change my fraction. And here notice that I'll be using an equality that a minus b times a plus b is a squared minus b squared. Hence here, I'll write this for once. Get square root h plus 4 squared minus 2 squared over h Oops, I meant to write it in red, but that's fine. And this is just the limit as h approaches 0. This is 4 plus h minus 4. So this is just h over h. Or you know what, let's write it, that's fine. Now notice the term here approaches square root of 2, square root of 4 plus 2. So it approaches 4. So this term, you don't need to touch it. The important idea is that you need to get rid of the 0 over 0. This term plays no role in the 0 over 0 because it approaches 4. So really, we should not touch it. We should just keep it. Neither expand it, nor factor it, nor do anything. Well, let's try to fit it here. This is h over h square root of 4 plus h minus 2. Plus 2. I can cancel the h out. And then evaluate by substitution. Well, by just plugging in, basically. Now, the most important idea here is to multiply by the conjugate. This is called by what we call the conjugate to get rid of the square root. Of course, I have to multiply that by on the top and on the bottom. Now let's move on. Of course, let's try to evaluate the top. The limit of the numerator is minus 4 squared minus, so it's minus 4 squared minus 16, which is 0. And the limit of the bottom, you can also check it to be 16 minus 4 minus 12, which is also 0. So I have a 0 over 0 that is indeterminate. Now here I still need to get rid of that indeterminate form. Luckily, we know how to factor quadratics. So the first one really just x times x plus 4. And the second one is x plus 4 times x minus 3. And then you can easily see that the x plus 4 cancel out. And then you can look at that plugin. You can just plug in that case, right? Like this is very easy. So it's minus 4 over minus 4 minus 3. So it is 4 over 7. Okay, now we look at this one, which is a bit more complicated. Of course, we try to always evaluate first. Always try to evaluate first the numerator and the denominator. So where does the numerator go to? Numerator goes to root of 4 squared plus 9, which is root of 25 minus 5, which is 0. And the denominator, of course, it's not very hard. I mean, it's very easy to see that it is 0. So I do have an indeterminate form of 0 over 0. Here, I mean, it's that trick of multiplying by the conjugate to get rid of the square root that comes in handy. Of course, we multiply by nothing other than whoops. Great. Well, now let's do that here. I mean, you can always expand it or use the fact that this is just the square of the first element. So, right, this is the square root of x squared plus 9 squared. Well, I wrote it again, but minus 5 squared over x minus 4 . Of course, the term in red approaches square root of 25 plus 5 approaches 10 as x approaches 4. So this term, we should not try to touch it. We should keep it as it is because it's not giving us any problems. It's not giving us a 0. So let's see what we get. So let's see, I get x squared plus 9 minus 25. So this is just x squared minus 16 over x minus 4 times the nice term that we have here, x squared plus 9 plus 5. Now here's try to evaluate. I mean, if you try to evaluate, you still get a 0 over 0. So really, I mean, we rewrote it nicely, but we did not get rid of that 0 over 0. But I mean, I assume now you can see how we do that by just factoring the top. My 0 in x squared minus 16 is coming because of the x minus 4 factor. Okay. Plus 5. I rewrote that. Now I can cancel the x minus 4 out. Boom, boom. And then now here I can simply plug in. So I get 4 plus 4 over 5 plus 5, which is just 4 over 5.